hello everyone. Just now we have seen Professor Sangal talking about this basics of stereological methods, and then he has also introduced a couple of probes. How are we going to analyze some of the spherical shapes or particle size and area measurements and point fraction and so on. What I am going to do is I will just take the actual microstructure which is of this nature. This is a microstructure of a cast iron. So, and we are going to use a probe of this nature which is of about a grid of this. So, now what I will do is I will now demonstrate using this probe how are we going to calculate the point fraction and then how that is related to area fraction, that is PP, and then again the second demonstration professor mentioned about how to measure the PL, that is which can be related to the average diameter of the particles of this microstructures. So, now let us go and do this measurements. After that what I will do is I will come back to this computer, then I will open an Excel sheet and take the data from each of the scholars who are measuring it, and then we will document it and then we will analyze it one by one. Okay, now let us start measuring this the PP first. So, what I am doing is I am placing this probe on the microstructure in a random orientation. So, let us not put like this, try to keep a symmetric, it should be random like this. So, I am just putting it like this. So, what is that first I have to do? I have to just count the number of grid points. So, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So, about 36 grid points I have. So, capital N is equal to 36. So, now I am just going to look at the number of intersections which is falling on this, each one of these spherical particles. So, now let me start counting now. 1, see the other important point you have to note down is the intersection point which is just touching this particle is counted as half. Okay. Even the line which is touching the periphery again counted as half when you do a diameter count, but then right now we are looking at the intersection point which falls on the particle. So, let me start doing that. So, this is 1 half and then 2 and then 3 because 2 and a half, 4, 4 and a half, 5 and then 6. So, this small n for this count is 6. So, I will have PP is equal to n by small n by capital N, that is 6 by 36. So, I will have for this measurement. So, now I will put this probe into different area of different random orientation like this. So, now let us start counting again. So, now this is 1, this is half 2 and then half, 2 and a half and then 3 and a half, 4 and a half, again it goes like this, and then this is about 4 and a half, right. So, 4.5 by 36. So, we will put one more random measurements somewhere here, and again start counting this. Let us see what is that we get. So, now this PP, I will start counting 1, 2, 2.5, and then this is 3.5, and then 4.5 again. So, this is n by capital N is equal to 4.5 by 36. So, like that what we can do is, when we take the averages of all this PP, we will get the average point fraction like this, what professor has written. So, what I will do is, I will collect this data from the entire class and put it in the Excel sheet, and before I go to that, let me also now demonstrate how I am going to use measure the PL. A PL. So, again I will put this grid into a random position, and then I will start counting the intersection of the boundary of the particle. So, now what we will do assume is, we will assume that the vertical lines are not there, we will use only the horizontal lines and let it fall on this microstructure. Let us look at the intersections. So, now I will start counting 1, 2, 3, 4, 5, 6, 7, 8, 8.5, 9, 9.5, 10 and 10.5, 11, 12, 13, 14, 15, 15.5, 16.5, 17.5, 18, 18.5, 19, 20, 20.5. Yes, it is 20.5. Now, this is per unit length. So, that L you have to now calculate. So, how do you calculate the L? You know this, for this micrograph, this length is about 20 micron. So, you put that line here, and then it is approximately 1, and then now it is 400 micron. So, it is approximately, it is about 600 micron. So, one line is 600 micron, 600 micron. So, now we have used 1, 2, 3, 4, 5, 6, 6 lines you have used. So, it is 600 into 6 is equal to 3600 micron is the total length. So, this, so like that we will put 20.5 divided by micron. So, this is event 1. So, now I will do the event again, another random orientation like this. So, the event 2 will start again, I will put a start measuring. I will use again one direction, this horizontal line, not the vertical lines. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12.5, 13.5, 14.5, 15, 15.5, 16, 17, 18, 19, 20, 21, 22, 23. So, even 2 is 23 divided by 3600 micrometer. So, even 3 I will put now, I will now measure randomly. So, now I am started counting this half, 1.5, 2.5, 3.5, 4.5, 5, 6, 7, 8, 9, 9.5, 10, 11, 12, 13, 14, 15, 16, 17, 18. So, even 3 gives me 18 divided by 3600 micron meter. So, like that we will take this and you can calculate this average PL for the number of events. What now I will do is, I will collect this data from the entire class. So, I will get the number of events is almost, we have about 9, 10, 11, 12, 13 students. So, even if I collect 2 measurements from each candidate, I will be able to get close to 30, because I have 3, 29, maybe I will collect 3 from each one of them. So, I will get about 36 event measurements, then I will put it into an Excel.